Hi kiddos, I'm back after eating a biscuit, ready to do some probability. Question number 28. So you've got 4 friends, each throw a biased coin a number of times. So in a normal coin, we'd expect the probability to land on heads be equal to the probability of it landing on tails, so which is half. But this is biased, so you expect different probabilities. One is more likely than the other. The table shows the number of heads and the number of tails each friend got. The coin is to be thrown one more time. Which of the 4 friends' results would give the best estimate for the probability that the coin will land on heads? Justify your answer. So the thing about probability and experiments in probability is that the more you repeat an experiment, the more accurate probabilities you're going to get. So the more times a person repeats an experiment, the more accurate their probability results are going to be. So all we have to do is check who threw the coin most number of times, and it's obvious it's Sharif. So Sharif's results will give the best estimate. Because he repeated the experiment. The highest number of times. There you go. Great, that's 1 mark. So we've got Paul who says, with this coin you are twice as likely to get heads as to get tails. So, well, let's have a look at Paul's results. And in his case, it's true because he gets tails 40 times and he gets heads double that, so 80 times. So for his results, that's true. But for example, if we look at Sharif, the probability that he's going to get heads, so getting heads for Sharif, it's actually 3 times as likely. Okay, so we can say he's not correct. Because he repeated the experiment. A smaller number of times than Sharif. And Sharif is 3 times as likely. To get heads. Okay. However, it is true for Paul's own results. Wondrous, 2 more marks. So then it says the coin is to be thrown twice. Use all the results in the table to work out an estimate for the probability that the coin will land heads both times. So if it's asking us to use all the data in the table, what I'm thinking of doing is seeing how many heads I have here all together. So if I add all these numbers across like that, I work out the total number of heads. And I did that earlier and I got 300 heads. And I do the same for tails. I did that earlier again and I got 100. Those are tails. So now I want to work out the probability of heads, and that's equal to how many heads I got, which is 300 out of how many times I repeated the experiment, which is 400 times. This is an arrow, okay? Don't get confused. That's just an arrow here. Same with that one. Okay, so we said 400 times altogether, which is 3/4 in its simplest form. So the probability of getting heads with this coin is 3/4. And we want to work out what's the probability of getting heads and heads, okay? Because it says it land on heads both times. So looking for the first one is heads and the second one is heads. And we know that and in probability we have to times. So the first one is 3/4 that he's going to get heads. The second one is also 3/4 because it's not going to be affected by anything. We just multiply them. 3 times 3 is 9, 4 times 4 is 16. And that's it. We worked it out. That's it, kiddos. I'll see you for some similar shapes in a few minutes. See you later. Bye.